Okay, then let's start with it. Chemistry. Let's start with organic chemistry. I'll only be saying the main or most important organic chemical reactions of class 12th in this video. Let's start with first one, alloalkanes. I'll be skipping all the theory part. I'll try to cover that later, as it takes too much time to cover organic chemistry if I go every single theory point. Let's go with just chemical reactions in this video. Alloalkanes and haloarenes. Okay. The first is preparation methods. Methods of preparation of haloalkanes. First one is Gru's process. Gru's process, reagent, concentrated HCl, and anhydrous ZnCl2, zinc chloride. Alkyl halides are obtained by heating alcohols with anhydrous zinc chloride and concentrated HCl. The general reaction is ROH plus HCl, zinc chloride, heating will give alkyl halide and H2O. There are specialities in this reaction. This reaction rate or rate order, it is the highest for tertiary, then secondary, then primary. It's the fastest for tertiary alcohol. Tertiary alcohol will show the fastest reaction. We don't even need to heat it. Immediately there will be a precipitate. Immediate reaction will give alkyl halide. For secondary, it is medium. It will take 1 to 2 minutes. For primary, the reaction won't take place unless we heat the reactants. This is the order. Why? Because of carbocation stability. Then this is the first preparation method. Second preparation method is Darzin's process, or from thionyl chloride. Reagent is thionyl chloride. This is the best approach or best method to prepare alkyl halide. General reaction, ROH plus SOCl2, this is thionyl chloride, gives RCl plus HCl gas plus SO2 gas. Both of the byproducts are in gaseous phase and will be liberated outside. So only the pure product will be obtained. Hence, this is the best method for alkyl halide preparation. Next, using phosphorus halides, specifically from alcohols, using phosphorus trihalide, general reaction 3ROH plus PX3 gives 3RX, and phosphorus acid, not phosphoric acid, it is phosphorus acid. And this is alkyl halide. Next is this is in case of, actually there are special methods. There is in case here, this is for X is chlorine, this will work out well. If it is for bromine and iodine, we need to follow one more reaction, that is to generate a phosphorus halide. It won't be directly available as phosphorus bromide or iodide. In case of phosphorus chloride, it will be available as phosphorus trichloride, but in case of phosphorus tribromide and triiodide, we need a special reaction. We need to produce the phosphorus trihalide at the time. So ROH plus, or in presence of a red phosphorus, and Br2 or I2, where X2, which is equals to Br2 or I2, it will give us our alkyl halide. Next, there is one more preparation method from phosphorus itself. It is, I think, fourth preparation method. Yes, fourth preparation method from alcohol using phosphorus pentahalides or pentachloride, ROH plus PX5. We don't need 5 reactants here, we only need 1. Will give us alkyl halide, hydrohalide, and phosphorus oxy trihalide. This is the reaction. Now fifth reaction is from alcohols again, using NaBr and H2SO4, sodium bromide and H2SO4. We take ROH plus NaBr plus H2SO4, which gives alkyl bromide NaHSO4 plus water. Then there is one more method which is not very efficient, free radical halogenation. In presence of sunlight. For example reaction, CH3CH3 plus Cl2 in presence of UV light and heat will give CH3CH2Cl and many other different products. It is not very efficient method. We will get a number of mixture of byproducts and the quantity of each byproduct is not assured. Then the next preparation method, from alkenes by adding halides. For example, if we take CH2 CH2 plus HX gives CH3 CH2 X, where X can be Cl, bromine or fluorine. In case of, this is a symmetrical alkene, symmetrical. In case of asymmetrical alkene like CH3 CH2, in this case, if we add hydrogen halide or hydrogen iodide, we need to follow Markovnikov's rule. Markovnikov's rule, the negative product, in this case hydrogen is positive, iodine is negative, the negative part will be attached to the carbon having the most substituted carbon. So CH3 CiH CH3 is the major product. But in presence of peroxide, it will not follow Markovnikov's rule. It will be a different mechanism. For example, actually there is no need to do that reaction right now. Let's go to the next reaction. Alkenes form dihalides. We have ethene, CH2 will react with bromine in presence of CCl4 to form vicinal dibromide. This is known as ethylene 1,2 dibromoethane. Ethylene dibromide or 1,2 dibromoethane. Then there are halogen exchange reactions. That's for the preparation methods. Then we have halogen exchange reaction. First one is Finkelstein reaction. Example is alkyl halide will react with sodium iodide in presence of dry acetone to give alkyl iodide plus sodium halide. This is the Finkelstein reaction. Then the second exchange reaction is Schwarz reaction. Schwarz reaction, we have general equation is alkyl halide will react with a higher metal fluoride to give alkyl fluoride and the higher metal halide, where X can be Cl or bromine. Here as well, above reaction, X can be Cl or bromine. These are the haloalkanes preparation and chemical reactions. Let's just see them once more. Haloalkanes, haloarenes, methods of preparation, Gru's process. Reagent is concentrated hydrochloric acid and anhydrous zinc chloride. The reaction order is tertiary greater than secondary greater than primary. Alcohol, this is due to carbocation stability. Alcohol will react with reagent to give alkyl chloride and water. This is the reaction. ROH will react with HCl to, in presence of anhydrous zinc chloride, to give RCl and H2O. This is Gru's process. And this reagent is known as Lucas reagent. Lucas reagent. Then Darzin's process, reagent is thionyl chloride, best method of preparation of alkyl halide. Alcohol will react with thionyl chloride to give alkyl chloride plus SO2 plus HCl. They will be, byproducts will be in gaseous form, so they will be liberated. Then we have from phosphorus trihalide, 3 from alcohol using phosphorus trihalide, 3 alcohol groups, 3 alcohols will react with phosphorus trihalide to give 3 alkyl halides plus phosphorus acid. And in case of bromine and iodine, alcohol will react with halogen in presence of red phosphorus to give alkyl halide. (3ROH plus PX3 gives 3RX plus phosphorus acid. This is the reaction, general reaction. Then from alcohols using phosphorus pentahalide, we get alcohol plus phosphorus pentahalide gives alkyl halide plus hydrogen halide plus phosphorus oxy trihalide. This is also a general reaction. Then another special method is from alcohol using sodium bromide and sulfuric acid to give alkyl bromides. Alcohol will react with sodium bromide and H2SO4 to give alkyl bromide, sodium NaHSO4 and water. Free radical halogenation. This is any alkane will react with chlorine in presence of UV light to give a alkyl halide product. From alkenes by adding halides, from unsymmetrical we use Markovnikov's rule. It's simple addition mechanism. Alkenes and dihalides in presence of CCl4 we will get, when alkene will react with bromine in presence of CCl4 we will get vicinal dihalides or vicinal dibromide. Alkenes will react with halogens in presence of carbon tetrachloride to give vicinal halides. Then halogen exchange reaction, we have Finkelstein reaction. Rx plus NaI in presence of dry acetone. Dry acetone is a reagent. Sodium iodide in presence of dry acetone is a reagent. We will get alkyl iodide and sodium halide. Schwartz reaction. Final product will have alkyl fluoride replacement reaction. Then coming to preparation methods of haloarenes. Haloarenes preparation method. First reaction, if we take 2 toluene will react with 2 moles of Cl2 in presence of iron and dark, we will get orthopara chlorotoluene, ortho and para product, plus 2 HCl. In case of, it's the same reaction, just in case of if it reacts with bromine, this is toluene, 2 toluene will react with 2 bromine in presence of iron and in dark surroundings, will give orthopara product of CH3 bromine plus CH3 parabromine, paratoluene, plus HBr. These are the 2 reactions. Toluene will react with bromine in presence of iron and the dark to give orthopara product of haloarenes and hydrogen halide. Then comes Sandmeyer reaction. Sandmeyer reaction uses BDC, benzene diazonium chloride. Benzene diazonium chloride is prepared from aniline. Aniline reacts with NaNO2, concentrated HCl plus NaNO2 at 0 to 5 degrees Celsius. This will give BDC. This can react with CuCl2 and HCl to give chlorobenzene, or CuBr2 in presence of HBr and 2 is the byproduct to give bromobenzene plus N2. This is Sandmeyer's reaction. As for this is preparation of chlorobenzene and bromobenzene. As for iodobenzene, when benzene diazonium salt BDC plus potassium iodide, it will give iodobenzene. We don't need any copper. Then fluorine also has a special reaction. I guess we will see that later for fluorine. So let's see the Sandmeyer's reaction once more. Aromatic primary amines react with nitrous acid prepared in situ from NaNO2 and a mineral acid such as HCl at low temperatures 0 to 5 degree to form a diazonium salt. This reaction is called diazotization. Freshly prepared diazonium salt is treated with cuprous chloride or cuprous bromide to give aryl chloride or aryl bromide. This is known as Sandmeyer's reaction. Iodobenzene can be prepared by simply shaking the diazonium salt with potassium iodide solution. That's for preparation of haloarenes. Now coming to chemical reactions. Chemical reaction of haloalkanes and haloarenes both. chemical reactions. They are divided into nucleophilic substitution, electrophilic elimination reactions, reaction with metal. When alkyl alkyl halide on heating with aqueous potassium hydroxide or aqueous uh, sodium hydroxide or moist silver hydroxides gives corresponding alcohol. This is the reaction. Alcohol formation. Through base reaction. We have three examples here, or three general reaction. Rx plus KOH aqueous gives ROH and KX. Rx plus NaOH aqueous gives ROH plus NX. Then we have silver hydroxide gives alcohol and silver halide. There is no need for two here, but it's because moist silver oxide is formed. So Ag2O, it will react with water to give AgOH. Because of that, we need to write 2 here. And this is on heating. The first reaction is alkyl halide on heating with either aqueous potassium hydroxide, aqueous sodium hydroxide, or moist silver oxide, which will give silver hydroxide. It will give alcohol and corresponding metal halide. Then there are two special reactions which need to be remembered. I will write them in the same category. Rx, this is cyanide formation reaction, cyanide or nitrile formation reaction. It is actually also isocyanide and isonitrile as well. I wrote it as cyanide only. General reaction is KCN, alcoholic KCN. If we heat alkyl halide and alcoholic potassium cyanide, we will get alkyl cyanide and potassium halide. Example, CH3I plus KCN alcoholic gives CH3CN plus potassium iodide. Then I'll write it again, isonitrile or isocyanide formation. It is Rx will react with AgCN. This is also alcoholic to give RNC. This is isonitrile or isocyanide, alkyl isocyanide. Example, CH3Br plus AgCN alcoholic gives methyl isocyanide plus AgBr. Okay. Next is fourth reaction. Alkyl halide will react with silver salts of carboxylic acid to form ester. This also will take it as R, gives RCOOR. This is ester and silver salt. Then next reaction is alkyl halide with alcoholic ammonia. Okay, ammonia plus RX one hydrogen will be replaced, it will become RNH2. Then RNH2 plus RX, second primary amine. Then second hydrogen will be released and will become R2NH. This is secondary amine. Then where R2NH secondary amine reacts with one more RX, it will give R3N. This is tertiary amine. When R3N reacts with RX, it will give quaternary ammonium salt. This is quaternary ammonium salt. Then two more reactions. When RX reacts with KNO2, it will give RNO2. When RX reacts with AgNO2, it will give RONO2. I mean not NO2, only N. Okay, just a second. When RX react with KNO2, it will give isonitrile, actually isonitrile, nitrite, not nitrite. It will give isonitrite. When RX react with AgNO2, it will give nitrite. plus AgBr, AgX plus plus Kx. Then reduction reaction, when Rx reacts with lithium aluminum bromide, like there is no need to mention this H minus, reducing agent like lithium aluminum hydride, it will be reduced to form alkane. Then we have SN1 and SN2 reactions. SN1 reaction, it has two steps: rate, tertiary greater than secondary greater than primary. Step 1, CH3, 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 Br plus OH minus. This is the reaction. There's no need for OH minus here, I guess. Okay, it will be a reversal process of, this will take it and it will become carbocation, sp3 hybridized carbocation. Then second step, plus OH minus can attack from here or here, will become COH, CH3, thrice COH. This is the final product. Then coming to SN2 reaction, here it is forming a racemic mixture. Coming to SN2, SN2 reaction, both are nucleophilic substitution. Here rate is primary greater than secondary greater than tertiary. CH3X plus OH minus, it will attack from backside. It will form bonds with carbon. This is a SN2 reaction. Then coming to elimination reactions. Ten reaction, dehydrohalogenation or beta elimination. For example, if we have an chloroethane, chloroethane, we have chloroethane. There is some, it is some in a base KOH, let's assume KOH. Then because of that there will be OH minus and K plus. Because of OH minus, this is a beta carbon. Chlorine is attached to alpha carbon. The carbon that is attached to the group is known as alpha carbon, and the carbon attached to the alpha carbon is known as beta carbon, and the hydrogen attached to the beta carbon is known as beta hydrogen. This hydrogen will be attracted by OH minus, and this will leave. This will leave as H plus. This electron will come here, and this chlorine will take the electron and will get attached to K plus, or there is no need for that, I guess. Just we need to know that bond will be taken by chlorine. It will become CH2 double bond CH2 alkene plus H2O plus X minus or chlorine minus. This is symmetrical. In case of unsymmetrical, it will follow the Sedzeff rule. Sedzeff rule states that during dehydrohalogenation reaction, the preferred product is the alkene which has greater number of alkyl groups attached to the doubly bonded carbon atom. For example, this is symmetrical. Now let's go for asymmetrical carbon. If we go with CH3, CH2, CH2, CHBr, and CH2. Now alcoholic KOH, we can write this like this, and this one as well like this. For this carbon there are 2 beta carbons, and these are beta hydrogens. So it can undergo, the product can be this one, CH3 CH2, where this can leave, C H double bond CH CH2 CH3, I mean this is CH2, or it can be either of them, but this product is the major product because double bond, according to Sedzeff rule, should go to the carbon having the more substituents. This carbon is having more substituents than this carbon, so this is the major product. Then that is elimination reaction. Then we'll do a reaction with metal. Reaction with metal. First one, or let's just follow the order, total number of reaction, we'll get an idea. 10 reaction, 10th reaction, now 11th reaction. Grignard reagent preparation. if it general reaction is Rx plus Mg magnesium in dry ether it will give Grignard reagent. This is the Grignard reagent. Example reaction CH3CH2Br plus Mg in dry ether will give CH3CH2 MgBr. That's about that reaction. That is Grignard reagent preparation. Then one of the main reaction, Wood's reaction. It is also a metal reaction. We have Rx, then Rx in presence of sodium in dry ether and heating. It will give, this will be gone and it will give RR, alkane plus 2NX. This is Wood's reaction. Then we have Wood's fatigue reaction. Wood's fatigue reaction, where we have phenyl ring plus again same reagent we'll get this plus 2NX. Then we have fatigue reaction where both are phenyl rings, and just a minute. Okay, let's continue. Then we saw Wood's reaction and Wood's fatigue reaction and fatigue reaction. Then there is, I think it was number 14, Dow's process. This is a nucleophilic substitution reaction of chlorobenzene. We have chlorobenzene will react with NaOH, 623 Kelvin, very high temperature and high pressure of 300 atm, then hydrolysis to give phenol. If there is any electron withdrawing group, the temperature and conditions for this reaction will reduce. For example, if there is one more reaction with presence of formation of picric acid, 15th reaction, Cl, NO2, will react with NaOH. Actually, there is no need for NaOH either. Just warm water to give picric acid. This is picric acid. Then there is halogenation reaction. If we take 2-chlorobenzene plus Cl2 in presence of FeCl3, it will give ortho-para dichlorobenzene. Para is the major product. Para always major due to steric hindrance. Then we have nitration reaction. Nitration of chlorobenzene. Chlorobenzene plus concentrated HNO3, concentrated H2SO4 will give ortho-para para-nitrochlorobenzene. This is the major. Ortho is minor, so I'm not going to write it as space is not there. Just plus ortho minor. Then there is sulfonation reaction. This will give a Zwitter ion, right? Not in this one, okay. It won't give a Zwitter ion. Chlorobenzene will react with H2SO4, concentrated, heated, will give ortho-para sulfonated or para-chlorobenzene sulfonic acid. This is a major product. Then there are finally Friedel-Crafts reactions. Friedel-Crafts reaction. Friedel-Crafts alkylation and acylation. Let's see alkylation first. We take chlorobenzene plus CH3Cl in anhydrous AlCl3 is the reagent. It will take chlorine from the CH3Cl, orthopara chlorotoluene or methyl chlorobenzene. Orthopara methyl chlorobenzene. Then we have Friedel-Crafts acylation. Where chlorobenzene will react with CH3COCl in presence of anhydrous AlCl3 to give again once more orthopara acetyl chlorobenzene. Then that's all the reactions. I think I didn't write Fitic reaction because there was no space. So I'll write Fitic reaction here. Fitic reaction. This will be removed in presence of dry ether. It will become diphenyl ring. That's about the reactions, the total reaction in this chapter, most of the reactions. Now let's do a quick revision of all the reactions. First, preparation methods for haloarenes, haloalkanes, Gru's process, reagent Lucas, reagent concentrated HCl and zinc chloride, anhydrous zinc chloride. Tertiary the fastest, depends on carbocation. ROH plus reagent will give alkyl chloride and H2O. Then Darson's process, sulfonyl chloride, ROH plus SOCl2 gives best like alkyl halide, alkyl chloride, HCl and SO2, sulfur dioxide. They both will be liberated outside. From alcohols using pX3, Three alcohols will react with px3 to give 3 alkyl halides and phosphorus acid, or alcohol will react with halogen in presence of red phosphorus to give alkyl halide. From alcohols using px5, alcohol will react with px5 to give alkyl halide plus POX3 plus HX. Then from alcohols using NaBr and H2SO4, ROH will react with NaBr and H2SO4 to give alkyl bromide plus NaHSO4 and H2O. Then sixth, from free radical halogenation, alkane will react with halogen gas or chlorine on the surface of water in presence of UV light to undergo free radical halogenation. The final product is a mixture of different products. From alkenes by adding halides follows Markovnikov rule if unsymmetrical, and a direct addition if symmetrical. Alkene plus HX will give alkyl halide. Markovnikov's rule states that during a hydrohalogenation, the negative part of the reagent should be added to the most substituted carbon. Then alkenes from dihalides. No, this is Wisner dihalide formation in presence of, like, alkene will react with bromine or halogen in presence of carbon tetrachloride to give vicinal dihalides. Alkenes will react with bromine or any kind of halogen in presence of carbon tetrachloride to give vicinal dihalides. Then halogen exchange reaction, Finkelstein reaction, it is alkyl halide will react with sodium iodide in dry acetone to give alkyl iodide and sodium halide, where X can be chlorine and bromine. Then Schwarz reaction, alkyl halide will react with higher metal, or like we can take an example of silver fluoride to give alkyl fluoride and silver halide. That is Schwarz reaction. Then haloarenes preparation method. First one, toluene will react with chlorine to give orthopara product and HCl in presence of iron and dark. Toluene will react with chlorine in presence of iron catalyst and in dark surroundings to give orthopara chlorotoluene. Let's read it once more. Toluene will react with chlorine in presence of iron catalyst in dark surroundings to give orthopara chlorotoluene. This can be example is, we can take toluene will react with chlorine in presence of iron in the dark to give orthochlorotoluene and parachlorotoluene or parahalotoluene is the major product due to less steric hindrance. Or in case of bromine, toluene will react with bromine in presence of iron in the dark to give orthobromotoluene and parabromotoluene. Parabromotoluene is the major product due to less steric hindrance. Then there is Sandmeyer's reaction for preparation. For Sandmeyer's reaction, we need to first prepare BDC, benzene diazonium chloride. Benzene diazonium chloride is prepared from aniline. Aniline reacts with concentrated hydrochloric acid in presence of NaNO2 to give at 0 to 5 degrees Celsius temperature to give BDC, benzene diazonium chloride. Salt, this will react with, Sandmeyer's reaction starts now. It will react with cupric chloride and hydrochloric acid to give chlorobenzene, or it will react with cupric bromide and hydrogen bromide to give bromobenzene. nitrogen is liberated. To get iodobenzene, we need to react BDC with potassium iodide. If we shake the solution a little, we will get directly iodobenzene. Then chemical reactions start. There are 3 types of chemical reaction: nucleophilic substitution, elimination, reaction with metal. The first reaction is alcohol formation with base reaction. Alkyl halide will react with bases such as aqueous potassium hydroxide or aqueous sodium hydroxide, or moist silver oxide. Moist silver oxide will react with water to give silver hydroxide. The final reaction is, general reaction is, alkyl halide will react with a base like potassium hydroxide to give alcohol ROH plus KX, or in case of potassium hydroxide it will give KX byproduct. In case of sodium hydroxide it will give NaX product. In case of silver hydroxide it will give AgX is the byproduct. The main product is alcohol. All 3 have common alcohol. Then cyanide or isocyanide formation. Rx will react with potassium cyanide to give cyanide group, alkyl cyanide. Yes, alkyl cyanide. Then the same alkyl halide group will react with silver cyanide to give, or AgCN to give isocyanide, alkyl isocyanide. This is due to KCN having ionic nature. It will give RCN. This cyanide, it will give cyanide. Because AgCN has covalent nature, it will give isocyanide. Then alkyl halide will react with silver salts of carboxylic acid to give esters. Alkyl halide with alcoholic ammonia. First there will be ammonia. Rx or alkyl halide will attack ammonia, and one of the hydrogens in ammonia will be substituted with the alkyl group. It will become a RNH2 primary amine. Then this primary amine will again get attacked by alkyl halide. One more of the hydrogens in ammonia will be replaced by R group. This will become a secondary amine. Then the secondary amine will get attacked by one more alkyl halide group. Then once more the third hydrogen will get replaced by R group. The fourth time the tertiary amine will react with Rx. This time the nitrogen will donate its lone pair to the R group to become a quaternary ammonium salt. Then a similar reaction as cyanide and isocyanide, we have nitrate and isonitrate, where alkyl halide will react with KNO2 to give isonitrate, and alkyl halide will react with AgNO2 to give nitrate. Then reduction, when alkyl halide will react with a strong reducing agent like LiAl, like lithium aluminum hydride, it will get reduced to give alkane and halide anion. Then there is SN1 reaction, where rate is tertiary greater than secondary greater than primary, just nucleophilic substitution reaction, where there is a racemic mixture. SN2 reaction, one-step reaction, direct substitution. There is an inversion, there is no racemic mixture. Optically active. Then dehydrohalogenation or beta elimination. If symmetrical, beta hydrogen will be eliminated, alkene will be formed. Beta hydrogen and halogen will be eliminated, alkene will be formed. If unsymmetrical, follows the Sedzeff rule. Sedzeff rule states that during dehydrohalogenation or beta elimination, the double bond is formed for the most substituted carbon, with the most substituted carbon. and that is a major product. Then there is preparation of Grignard reagent. Alkyl halide will react with magnesium in dry ether to give Grignard reagent RMgX. This is known as Grignard reagent. Then Wood's reaction. Two alkyl halides will react with sodium in dry ether to give alkane. Wood's-Wittig reaction. Aryl halide and alkyl halide will react with sodium in presence of dry ether to give, for example, if we take chlorobenzene will react with chloromethane in presence of sodium in dry ether, we will get toluene plus sodium chloride. Then Dow's process, when chlorobenzene is a substitution reaction, this chlorobenzene will react with NaOH, then hydrolysis in 623 Kelvin high temperature and 300 atm pressure, very high pressure, to get replaced to form phenol. This is known as Dow's process. When there is an electron withdrawing group, the conditions will drastically reduced. Example is when 2, 4, 6, I think the name is 2, 4, 6 trinitrochlorobenzene. When this one 2, 4, 6 trinitrochlorobenzene can, because of 3 nitro group substituents and nitro group being a strong electron withdrawing group, because of that only in warm water it will react to give picric acid, which is basically 2, 4, 6 phenol, trinitrophenol. Then 15th reaction, when chlorobenzene, this is chlorination reaction, when chlorobenzene will react with chlorine in presence of iron trichloride, it will give orthopara dichlorobenzene. Para dichlorobenzene is the major product because of steric hindrance being less. Let's see this reaction again. Chlorobenzene will react with chlorine in presence of iron trichloride to give ortho and para dichlorobenzene. Then we have 16th one. This is nitration reaction, ortho-para product. When chlorobenzene reacts with concentrated HNO3 and H2SO4, this will give a NO2 plus electrophile. This will get attached in the ortho and para position to give orthonitrophlorobenzene and paranitrochlorobenzene. This is paranitrochlorobenzene is the major product due to least steric hindrance. And there is sulfonation reaction, where chlorobenzene will react with concentrated sulfuric acid to give orthopara chlorobenzene sulfonic acid. Yes, orthochlorobenzene sulfonic acid minor and parachlorobenzene sulfonic acid major. Then finally we have Friedel-Crafts alkylation and acylation reactions, where chlorobenzene will react with CH3Cl. This is alkylation reaction, CH3Cl example, in presence of anhydrous AlCl3. Anhydrous AlCl3 will react with chloromethane to produce electrophile CH3+. This CH3+ will attack in ortho-para positions of the chlorobenzene to create orthomethyl chlorobenzene and paramethyl chlorobenzene. Paramethyl chlorobenzene is the major product. Then acylation. Acetyl chloride is the reagent. Acetyl chloride will react with anhydrous AlCl3 to produce an electrophile CH3CO+, where carbon will have the positive charge. It's a carbocation. This carbocation will attack the chlorobenzene in ortho and para position to produce ortho-para acetyl chlorobenzene. Para-acetyl chlorobenzene is a major product. Then we have Fittig reaction. Fittig reaction. Haloarine, two haloarenes will react in presence of sodium in dry ether to produce diphenyl ring and sodium halide. That's it for haloalkenes and haloarenes.